Alright, in this lesson we are going to learn about parallel lines that are being cut by a transversal and all the special angle pairs that are generated by that. But first, the vocabulary. Alright, well, we'll worry about this later, but the angle pairs, when you have two lines cut by a transversal. The transversal is the line that's cutting across the two other lines. So whenever this happens, you generate four angles, okay? 8 in total. So I want you to take a look at this intersection, and can you see the four angles that are here? Like I could call this angle 1, 2, 3, and 4. Now if you look at this intersection right here, there are four more angles. 1, 2, 3, and 4. So we're going to talk about the relationships between all of these. So first of all, corresponding angles are the angles that are in the same position on their intersection. So if you look at these angles up here, you see how angle 1 is in the upper right hand corner? And now if you look at this intersection down here, do you see how the angle 1 down here is in the upper right hand corner? So angle 1 yellow and angle 1 blue, those are corresponding angles. And same with all the other numbers. Angle 2 and angle 2, angle 3 and angle 3, angle 4 and angle 4. Alright, those are each corresponding angles. Let's see, what else do we have? I want to do that later. Now, looking down here, alternate interior angles. So, to be clear, let me just pick like one good example. So, this was angle 1. So, angle 1, these are corresponding angles. Okay? Now, alternate interior angles. Interior means between the lines. Alternate means on opposite sides of the transversal. So for example, this angle right here and this angle right here, these are alternate interior angles. Okay, and I could do it on the other side too. This angle and this angle, these are also alternate interior angles. Alright, eventually you'll need to memorize these. Let's see. Now, there's something called consecutive interior angles, or sometimes they're called same side interior angles. Again, interior means between the lines, but these will be on the same side. So this angle and this angle, these are consecutive interior angles, same side interior angles. Now, see this word exterior angles. That means it's going to be outside of the two lines. Alternate, again, means on opposite sides of the transversal. So that would be like this. This is an exterior angle, and this would be the alternate exterior angle. Okay? So there's one more pair that we could do. If I pick this angle, then this angle would be the alternate exterior angle. Alright, so you need to be familiar. What else we have? Vertical angles, we've talked about that before. When these lines intersect, these angles that share a common vertex, these are vertical angles. And it has to be straight lines intersecting that will create these vertical angles. Alright, and there's another pair down here. I'll change colors to show that it's a different situation. But these blue angles, these are vertical angles. Okay, I could switch it up and go the other way if I can remember which way I did it the first time. I'm going to use this color, green. So these angles are vertical angles. I don't actually remember if that's what I did before or not. Anyway, you get it, vertical angles. Linear pair, something else that we've talked about. When you have a straight line and you've got the two consecutive angles, those are a linear pair. So this angle and this angle together are a linear pair. Same thing down here. If this is angle 1 and this is angle 2, angle 1 and 2 are a linear pair. Alright, so that was a quick run through of the vocabulary. So, let's see if we can practice that. Classify each pair of angles as one of the following. And we have our little word bank here. Okay, so look at angle 9 and 16 and see if anything's going on there. Alright, so here's angle 9 and here's angle 16. Notice that they are outside of the two lines. So if anything, they're exterior. And they are on opposite sides of the transversal. So these are alternate exterior angles. Okay, so let's see, alternate exterior angles. So we can put C for that. Number 2, how about angle 15 and 11? Okay, so here's 15 and here's 11. Now these are consecutive angles. They form a straight line, so that's a linear pair. Okay, so does it say linear pair? Linear pair is not, wait, supplementary angles. Alright, a linear pair, which this is, but they're also going to be supplementary. Okay, so we'll put E. Alright, for our supplementary linear pair. Number 3, 10 and 15. That's not a pen. Alright, so there's 10 and there's 15. Notice how they're both between the lines here. They're between. And they're on opposite sides. So they're interior angles and they are alternate interior angles. So that's A. Number 4, 12 and 15. 12 and 15. Angles like this that are right across from each other, right, formed by intersecting lines, these are called vertical angles. Vertical angles. So that's D. 9 and 11. So here's 9 and here's 11. Now, see how they are in the same position? If I look at this intersection and this intersection, 9 is in the top left corner and 11 is in the top left corner. So when they're in the same position like that, they are called corresponding angles. So that is B. Alright, how about number 6, 9 and 15. So let's see, here's 9 and here is 15. That is nothing. Okay, they're not corresponding angles, because that would be like, if I was going to do 15, the corresponding angle to 15 would be right here. So they're not corresponding angles. They are alternate, I guess you could say, but they're neither interior, alright, they're not both on the inside, nor are they exterior, they're not both on the outside. So there's nothing that matches these, so we'll put F for none. Alright, number 7. 13 and 14. Okay, this is another linear pair, and they will be supplementary. Again, so that's E. 14 and 11. Okay, so these are alternate interior angles. They're between the lines, so they're interior. They're on opposite sides of the transversal, so they are alternate interior. Okay, so that's A. Alright, seems like there was no choice for same side interior. Okay, so that didn't come up, but I was waiting for them to say like 10 and 11. Those would be consecutive interior or same side interior. Anyway, it didn't happen. I'm going to have to let it go. Alright, moving on to number 9. So looks like we're given some degrees. All right, are we given any more information? Okay, so we're given some degrees, and I guess we're being asked to find this other stuff. So let me put these in. So angle 2 is 97 degrees. And angle 6 is 83 degrees. Okay. Alright, let's see what we can find out. Do I know what angle 3 is? Yes. These are vertical angles, so angle 3, the measure of angle 3 will be 97 degrees. What about angle 5? Well, angle 5 and angle 6 are a linear pair. Okay, so these are supplementary. So all I have to do is do 180 minus 83, since I have to add up to 180. Okay, so see, 180 minus 80 is 100. Minus 3 more is 97. So this will be 97 degrees. Interesting. Okay, alright, so maybe I should write some of these down. I'll worry about it later. Angle 10. Jumping all the way over to angle 10. Let me pause this method. Alright, they didn't give us any directions here ahead of time to tell us that T and S are parallel. They mention it down here, like for number 10, find X given that S is parallel to T. That's the symbol for parallel. But to know the measure of angle 10, we have to know that these are parallel. So I'm going to go ahead and assume that they meant to tell us that these are parallel. If they are parallel, then corresponding angles are equal. And angle 2 and angle 10 are in the same position. They're both in the upper right-hand corner of the intersection. So that would make angle 10 97 degrees. Okay, maybe I'll just fill that in right here. Angle 7, well, these are vertical angles. All right, so that'll be 83 degrees. Angle 9, well, these are supplementary. All right, they're a linear pair. So I could do 180 minus 97. It's off camera. So that's 83. Okay, and angle 16. Well, I didn't write it down, but a while ago we found that angle 5, the measure of angle 5 was 97. So let's say if I write that in right now. And let me erase some other stuff for a second. Alright, angle 5 was 97 degrees. So there's my 97 again. And now we're being asked for 16. So looking at these parallel lines being cut by transversal, angle 5 and angle 16 are alternate exterior angles. Alright, they're on the outside of the parallel lines, and they're on opposite sides of the transversal. And guess what? Alternate exterior angles are congruent. So if this is 97 degrees, then angle 16 will also be 97 degrees. Alright, number 10. Again, so they're telling us S and T are parallel. Okay, so we have parallel lines cut by a transversal. If they say that angle 4 is 77 degrees, so okay, this is 77 degrees, and the measure of angle 8 is 4x plus 57. So that's this right here. Okay, you know what, let me not clutter up this picture. So look, we're dealing with angle 4 and angle 8. These are corresponding angles, alright? They're both on the lower left side lower left side. These are corresponding angles, and if you have parallel lines cut by a transversal, corresponding angles are congruent. So that means the measure of angle 4 and the measure of angle 8 are equal. So that means that 4x plus 57 should equal 77. So subtract 57 from both sides. So that's going to be 20. So 4x is equal to 20. Divide both sides by 4. And you find x. So x is equal to 5. Now be careful. Are we supposed to find x, or are we supposed to find, the measure of some angle? Well, they said find the value of x, so we're good. Alright, now how about angle 3 and angle 5? Let's identify those. Okay, here's angle 3, and here's angle 5. These are alternate interior angles. And if the lines are parallel, alternate interior angles are congruent. So once again, these should be equal to each other. So 5x plus 13 should equal 53. Alright, so subtracting 13 from both sides, that's going to give us 5x is equal to 40. And then you divide both sides by 5. Okay, so we get x equals 8. Alright, how about number 12? So number 12 involves angle 1 and angle 7. So here's angle 1 and here's angle 7. These are alternate exterior angles. And if the lines are parallel, alternate exterior angles are equal. So big surprise, once again, we will set these equal to each other. So 6x minus 5 should equal 115. So we should add 5 to both sides. So that'll give us 6x is equal to 120. And then we will divide both sides by 6. Alright, and that will give us x equals 20. Alright, so that's number 12. Alright, this is basically the same thing, just worded differently. Find the value of x that makes j parallel to k. Well, if j is supposed to be parallel to k, then angles like this should be congruent. Alternate interior angles. So once again, we're just setting these equal to each other. So 3x plus 10, let me do it the other way because I want positive numbers and such. So 5x minus 10 should equal 3x plus 10. Whenever you have variables on both sides, subtract. Okay, so that's going to give me 2x minus 10 is equal to 10. Then I would add 10 to both sides. Okay, so that's going to give me 2x, these cancel, 2x equals 20. And then you divide both sides by 2. So of course, x equals 10. Okay, number 14. Well, it really doesn't matter if these are like parallel or not. In fact, this question doesn't really apply as far as these being parallel, but vertical angles are equal, so we can still find x, but finding this has nothing to do with these lines being parallel. Anyway, 3x has to equal 75. We'll divide both sides by 3, and that will give us x equals 25. Alright, same thing for number 15. If these are supposed to be parallel, corresponding angles like these, that's what these are, should be congruent. So 6x should equal 5x plus 15. let us subtract 5x from both sides. Whenever you have variable on both sides, eliminate one. So this will give me x equals 15. So that's number 15. Very nice. Same deal for number 16. If these lines are to be parallel, then alternate exterior angles, such as these, should be congruent. So 4x minus 20 should equal x plus 10. Subtracting x from both sides, I have 3x minus 20 is equal to 10. Add 20 to both sides. Okay, so that's going to give me 3x equals 30. Divide both sides by 3. So x is equal to 10. So that's it for number 16. Alright, for number 17 and 18, I feel like we're missing some information, some directions. There's no way to know what x is unless we assume that this is supposed to be a right angle. So maybe in the directions should have said, determine the missing angles, you know, if this is a right angle. I don't know. So let's go ahead and assume that we have no choice. So if this is a right angle, you know, if these are then complementary, then we can just do 90 minus 55. And that would make this 35 degrees. Okay, but you really aren't supposed to assume that it's a right angle, so that's bad form. But I don't see any other way. Same thing with number 18. If we assume that this is supposed to be a right angle, then we're doing 90 minus 47. So you know what that's going to be. 90 minus 47 is 43. So y is equal to 43. Alright, if this is a right angle, which they didn't tell us. But I'm going to let that go. This is clear, alright, even without directions, because we do have a linear pair. So we know these will be supplementary automatically. So these have to add up to 180. So that means we're talking about 180 minus 67. Alright, so you get that 113, yes? So this is 113. Same thing here. 180 minus 122. So that's 58. Alright, and that is it for this lesson. I hope it was helpful. I will see you on the next video.